Hello students, welcome to my YouTube channel Fun with Chem. Today I'm going to discuss 2025 Jan Unit 4 MCQ part. So we'll see the first question. Which reducing agent is used to convert carboxylic acid to alcohols? So we know it's a very common one. The correct answer is acidified potassium dichromate. So when you use acidified potassium dichromate, right, it is K2Cr2O7. It is orange in color. And in that you have chromium in 6 plus oxidation number. It will be reduced to Cr3 plus, then you get a green solution. And then the alcohol, the primary alcohol, will oxidize to a carboxylic acid. So this is a redox reaction where the reduction of the dichromate happens and the oxidation of the alcohol take place. Concentrated sulfuric acid we can't use for that. These are wrong. They are used for different purposes, not to oxidize an alcohol. A polyester is made from pentane 1,5-diol and pentane dioic acid. So first children, I should draw the compound. Pentane means it should have 5 carbon atoms. 1,5-diol means on the first and the last carbon, I should have 2 OH groups. So this is the structure of pentane 1,5-diol. Then I have pentane dioic acid, which means that there are 2 carboxylic acids at the two ends. So I can write it as 1, 2 here. So 3, 4, 5. I need to put 3. Then only I have 3 carbons, 4 and 5. It will be pentane dioic acid. So normally this is coming under condensation polymerization, where hydrogen is removed from the alcohol group, OH is removed from the carboxylic acid. So here also, if I write it correctly, O and H, hydrogen is removed from the alcohol. From the carboxylic acid, OH will be removed. So I will get OCH2, 1, 2, 3, 4, 5. So I can put 5, then another O, and then carbonyl group will come CH2, 3, CO, another continuation bond. So we can see which one is the correct answer. Ester bond will not form at the beginning. It is formed in the middle only. Therefore, A is wrong. In B also you can see the ester bond at the beginning. B is also wrong. In C, you can see carbonyl group is there. Then CH2 thrice. Again, the ester bond. Then CH2 5 times and O. C is the correct answer. This is wrong because this is not pentane dioic acid. This is 5,6,7 heptane dioic acid. Because of that only D is wrong. Then the third one, when ammonia dissolves in water, an equilibrium result is given. Which of these species act as a Bronsted-Lowry acid in this equilibrium? So if you take the reactant ammonia, it became ammonium. So that means it has accepted a proton. This is acting as a base. If you take water, water becomes OH. That means water has donated a proton. It is the acid. That is for the forward reaction. If I take the backward reaction, ammonium becomes ammonia by removing a proton. Removal of a proton is an acid. OH minus becomes water by accepting a proton. So it is a base. So which ones are acting as acids here? So we can see water and ammonium. So the correct answer is D. Then we see the next one, a strong monoprotic acid of concentration 0.01 has a pH 2. What is the decrease in pH if the concentration is increased to 0.011? So children, first we need to find the pH of that acid. Minus log, monoprotic means it has only one, like HCl, 0.011. So if you find the pH, it's minus log 0.011, you get it as 1.95. Initially it's 2, so they have asked for the decrease in pH. From 2, if you subtract 1.95, you get the answer as 0.04, and the correct answer is B. Then the fifth one of the stages in the manufacture of sulfuric acid involves the oxidation of sulfur dioxide. What is the numerical value of Kp at 25 using equation 2? So if I write the expression for Kp for the first equation, children, I can write it as PSO3 twice PSO2 and PO2. For Kp dash, I'll take this as Kp dash. I can write as PSO3 divided by PSO2 into PO2 half. So if you take the relationship between Kp and Kp dash is like the square root of Kp. Kp is the square root of Kp dash. So we know the value of Kp, 4 into 10 to the power 24. To find the Kp dash value, we need to take the square root. So it should be 2 into 10 to the power 12. So the correct answer is A. The relationship between Kp and Kc is given when T is the temperature in Kelvin. What is the value of Kc? For equation 1, right? Okay. For equation 1, Kp is already given 4 into 10 to the power 24 divided by gas constant is 0.082 into 298. Delta N is the products minus reactants. So, or reactant. Delta N is products 2 minus 3, you get minus 1. Then this is minus 1. So you can take it up. Then you will get the answer as if I take it up, 4 into 10 to the power 24 into 0.082 into 298. So the answer is 9.77 into 10 to the power 25. I got minus 1 because it is the number of moles of the products minus number of moles of the reactant. So when I get a negative 1, to remove that, I should take it up. Then I have to multiply everything by 4 into 10 to the power 24. Then only you get the correct answer. Which equation represents the standard enthalpy change atomization of iodine? So in atomization, it's always for 1 mole of gaseous atom. So you can easily omit C and D because they have 2 moles. Then it should be from a elements. So initially, or the under standard condition, iodine is a solid. So the correct answer is A, from solid to a gaseous atom. Then the next one, which equation represents the second electron affinity of oxygen? So if I write for the first electron affinity, O gas with E minus, you get O minus gas. Normally, first electron affinity has a negative value, right? Negative value. So I'll write it again. Second electron affinity, O minus gas with one electron, you get O2 minus gas. So it has a positive value. That is because we are adding an electron to a ion that has a negative charge. So there can be repulsions when you try to give an electron. Therefore, some energy is required to overcome the repulsions. That is why it is positive. So always remember, if you have a ion with 2 minus charge, first electron affinity of any element is negative, but the second electron affinity is always positive. So according to this, the correct one is A. Then eighth one, which compound has the greatest covalent character? So if you take the two cations, Ca2 plus and Mg2 plus, we know the charge is the same, right? When they ask about the covalent character of ionic bonding, right, we need to look at two things. One is the polarizing power of the cation. Polarizing power of the cation. For that, the charge should be higher and the radius should be smaller. The other one is polarizability of the anion. For that, radius should be larger. Charge also should be larger, right? So if you take magnesium and calcium, we know calcium is larger. Therefore, it has a less polarizing power. The more polarizing power is for magnesium. So we can easily omit A and B. Then you have to compare the negative charges, bromide and iodide. So we know iodide has a larger radius, even though both of them have the same charge. Therefore, the polarizing power is high in magnesium, polarizability is high in iodine. So the one with the greatest covalent character will be magnesium iodide. Which pair of values will always give a thermodynamically feasible reaction? Right? For that, children, we need to know that total entropy is equal to entropy of the system and entropy of the surrounding. And we know entropy of the surrounding is given by minus delta H over T. So using that only, we have to find the answer. Entropy change of the system. System, if it's negative, okay, we'll take system is negative, right? Then enthalpy change of reaction is positive. So if this is positive, minus into positive, you get a minus charge. So E naught or E total, sorry, entropy, total entropy will be negative. So it is not a feasible reaction. For a reaction to be feasible, total entropy should be positive. Right, then we'll see the next one. Entropy change is negative, enthalpy change is negative. Then negative and negative, you get a positive value. Then you get a condition, then this one should be greater than the magnitude of system. Then only you get a positive answer. So without that condition, we can't say that it's always feasible. Then we take the next one. We have delta S system minus delta H over T. Entropy is positive, enthalpy is negative. Then negative into negative, both of them will be positive and the total entropy also will be positive. So C is the correct answer. If you take D, if this is positive, plus and minus, this will be negative and there should be a condition that magnitude of system should be greater than the surrounding. Therefore, if you have total entropy change of the system positive, enthalpy change of the system negative, then the total entropy is always positive. If the total entropy is positive, it is thermodynamically feasible without any condition at all times, right? Then we'll see the 10th one. What is the effect, if any, of increase in pressure on the appearance of the equilibrium mixture? So you can see for pressure, always we need to look at the number of moles, right? Here this side also you have 2 moles. This side also you have 2 moles, right? What is the effect, if any, of the increase in pressure on the, so you can see there are 2 different gas molecules on this side. So when you, pressure is anyway high on this side. So when you increase it at once, so we can't say like that, because when we have 2 moles and 2 moles, the pressure is equal. But when you increase the pressure, because of the color of iodine, you can see it as it becoming more purple. For example, if you have, we'll say something like that, you have only iodine vapor, right? And if you're increasing the pressure, that means you're decreasing the volume. Then what will happen? It appears more purple because the volume is reduced. The only way we can increase the pressure is by reducing the volume. Nothing will happen to the equilibrium mixture, as both of them contain the same number of moles. But you can see it becoming more purple. That is not because the system has shifted towards the left-hand side, but because of the color intensity when you reduce volume, right? So the correct answer is, what we can observe is the mixture become more purple, because others are colorless gases. Hydrogen and HI are colorless gases. So when you have a colored gas uh, in a higher pressure, it becomes purple. The equation for the manufacture of ammonia by the Haber process is given. Which change, if any, will result in an increase of Kp value? So remember, children, you can change the Kp value only when you change the temperature, right? So pressure is wrong. When you decrease it, it's correct, because in an exothermic reaction, products have a high temperature. So when you reduce the pressure, system tries to form more products. And Kp is given by products divided by reactants. So when products increases, Kp also increases. That is correct. These will not change Kp. Only changes in temperature will change Kp and Kc. The equation for the equilibrium between nitrogen oxide and dinitrogen tetroxide is shown. A change in conditions result in Kp increasing from 0.115 to 3.89. Okay, that means the pressure is increasing. That means the position of equilibrium has shifted towards the right-hand side to increase the pressure. What can be reduced about the change in the position of equilibrium? For this change, they might have reduced the pressure. That's why in order to increase the pressure, more products are formed. So you can easily say the equilibrium position has shifted towards the product. We can increase the pressure only by forming products, because this side we have 1 mole, this side we have 2 moles. So this is the prediction we can make. What is the pH of 0.1 solution of sodium hydroxide? So children, we know sodium hydroxide is a strong base. Therefore, it will dissociate like this, Na plus and OH minus. If you have 0.1 moles per cubic decimeter of sodium hydroxide, that means you have 0.1 moles per decimeter cube of OH minus. We can find pH if we know the H plus concentration. Therefore, we need to use the ionic product of water, which is equal to OH minus and H plus. They have given the pKw. That means we have to take minus log of everything. Then you get pKw is equal to POH plus pH, right? Then this is given as 14.53. If you take minus log of 0.1, which is the concentration of OH, it's 1 plus pH. So pH is equal to 14.53 minus 1. The correct answer is 13.53. So remember, children, normally Kw is given as 10 to the power minus 14. If you substitute with this answer, you get A as the answer, which is wrong. So you have to use what they have given. To get pKw, you need to take, this is the equation, ionic product of water, H plus and OH minus. To get pKw, you take minus, okay, I'll write in a different line. If you take minus log of everything, minus log H plus minus log OH minus. So here it's pKw, here it's pH, here it's POH. This is what you are getting. The pH of a dilute solution of a weak carboxylic acid can be calculated from its Ka value, which is not a relevant assumption in the calculation of pH. So children, if I take a carboxylic acid, right, we know it has a reversible dissociation because it partially dissociates to give these two, right? Then if I write Ka, we can write carboxylate H plus and acetic acid. So when finding the pH value, we are making one assumption. That means formed acetate is equal to the form H plus. The other one is initial concentration of the acid is equal to the equilibrium concentration of the acid. Then after that we are getting H plus squared divided by the concentration of ethanoic acid at equilibrium. Then we'll see which is not a relevant assumption. The ionization of water is insignificant. That is correct because in this we can assume that water will also ionize as H plus and OH minus, so that also should be included. But we are assuming that it is insignificant. The initial and equilibrium concentration, that is correct. Concentration of the protons and the carboxylic, that is this assumption, which is correct. Dissociation of that is wrong because carboxylic acid is a weak acid and the dissociation will not be almost complete. It partially dissociates. This is only correct when you have a strong acid. Then 13th one, what is the pH of a buffer solution? 0.01 and 0.2. Okay, so they have already given everything. The Ka is given. To find pKa, right, we need to take minus log Ka, which is equal to pKa. If the Ka value is given, to find the pKa value, we need to take minus log 1.7 into 10 to the power minus 5. So we can find the pKa value as 4.769. So 4.769 plus log concentration of the salt is 0.2, concentration of the acid is 0.1. Then I can write 4.769 plus log 2 is 0.33010. For that, if I add 4.769, you get it as 5.07. Correct answer is 5.07. So it's very easy just to substitute to the equation. What is the best reason for the use of buffers in food? So we don't use buffers to improve the taste. It doesn't help in digestion either, but it helps in preventing deterioration by fungal activity, because we know fungus, like, they have a optimum pH, right? So when you have buffer solution, the pH will range a lot. Therefore, it will prevent the deterioration by fungal activity. You have a range of pH. The carbonic acid they have given, how is the pH of blood affected by increased exercise? So we know in increased exercise will increase the H plus concentration. Metabolic activity will be high. So when you increase the H plus, pH will decrease, because there is the inversely proportional relationship between H plus and pH. So we'll see the correct answer. There is no effect because the equilibria are not affected. That is wrong. With increasing H plus, the only answer we can say is the pH will decrease due to the equilibrium shifting to the right, because of the inversely proportional relationship between H plus and pH. Which has the greatest molar entropy? So normally we know if you take solid, liquid and gas, gases has the highest entropy. Then out of these two, the other one, we have to consider the one with more electrons. Therefore, the correct answer will be NO2. What is the half-life of this decomposition? So we can see 9 is the initial one. Half-life is 4.5. So you need to find the time taken for it to be 4.5. So roughly it should be 132 minutes, right? So the correct answer is B, 132 minutes. Okay, children. So in this video, I just want to discuss only the MCQ answers, as only the answers are given in the marking scheme. Thank you for watching, children. So like and subscribe for more videos. Have a nice day.